All right, folks, so we have another set of notes today. This is about classifying matter, the different types of matter we can have. Just as a uh, review, matter is any type of atom, element, compound, or mixture. Essentially, it has a volume and it takes up space and it has a mass. So obviously it would have a density too. You should know that. But all of these particles that we talked about when we were talking about solids, liquids, and gases, those particles, we call them atoms or molecules, depending on what exactly they are. So when I say the word atom, don't get confused. Just think of it as a small particle, the smallest particle you can have, really. Elements and compounds, those are types of pure substances. An element could be more than one atom stuck together, could just be one atom, but no matter what, there's only one type of element there. So if you look on the periodic table and you find an element and you put a bunch of atoms of that element together, as long as there's no other elements anywhere within that, we call it an element. So could have a million atoms stuck together. As long as they're all the same element, it's still just an element. Our example here with the Lego bricks, it's two red bricks stuck together. They're the same thing, even though they're stuck together. Or you can have two oxygen atoms stuck together. It's still just oxygen. It's not any kind of special compound. It's just an oxygen molecule. Now, a molecule is any time that you have two or more atoms stuck together. It doesn't matter what they are. If there's atoms stuck together, it's a molecule, just as a side note. And we have compounds, which have to have two or more different types of elements. So you could have 100 different atoms. 99 of them could be one type of element, but if there's one different type of element within that group of 100 and it's all chemically combined, then we call it a compound. So our Lego example is you've got two blues and one red, and they're all stuck together. So there's two different types of elements. That's a compound. That molecule would be a compound. This is a molecule of water. It's got two hydrogens and one oxygen. There's more than one type of element, so it's a compound. Both of these are called pure substances. We call them pure substances because they can't be separated without a chemical reaction. There's no way to pull these pieces apart without having to undergo a chemical change. So we also have mixtures. A mixture can be separated through a physical change. You don't have to go through a chemical change to separate the pieces. So like these Lego bricks here, I can pick up the green Lego brick and take it out of the mixture, and I've separated it, but I haven't changed how the pieces are configured. I just moved them. Okay. Same idea with this mixture of elements down here. There's the purple elements stuck that are the molecules with two of the purple elements stuck together. There's the green elements, and it's a mixture of those two together, but you could separate them physically if you wanted to. So those are the three big types of matter that I want you to get: elements, compounds, and mixtures. We're going to do a lab here soon about classifying each of those as you look at examples that are symbolic of these. More end-focused with this, an element, we can classify an element as being a metal, a non-metal, or a metalloid. And we'll really get into that when we talk about the periodic table soon. Again, the atom structure of it, it could be one atom or it could be more atoms and make a molecule, but it has to all be the same element, and they would have to be chemically combined. So an example would be like a copper pipe or aluminum foil. The metals that you see here, they're usually transition metals, which, again, we'll talk about when we look at the periodic table. But they're the best ones at just hanging around and being an element by themselves. All the other types of metals are highly reactive and like to be stuck with other types of elements. But anyway, our compounds, which are more than one type of element stuck together, we could classify them based on their pH, whether they're an acid or a base. We could classify whether they're organic or inorganic, which means do they have carbon or do they not have carbon. We could classify them based on their role in biology. Are they carbohydrates or lipids or proteins or nucleic acid? And all that stuff is really cool science stuff that I would love to teach you about, but we're just not going to quite go too far into it. But atoms, or the atom structure of a compound, it has to have two or more atoms of different elements. And those elements have to be chemically combined. If they're not chemically combined, then it's not a compound. So an example would be like water or sugar. This is a sugar molecule. You can see there's different elements within that, and they are bonded together. That's what those little sticks between them are. Or dynamite, TNT, trinitrotoluene. Again, you can see the different elements there and the sticks that hold them together. So those are all examples of compounds. And then mixtures are something you should probably be more familiar with. We can classify mixtures as heterogeneous or homogeneous. Heterogeneous mixtures are not the same throughout. You can see the different pieces. So like a salad here, you can see the carrots and the green lettuce and the cabbage and all of that stuff within it. So it's a mixture of different things, and you can see those different parts. So it's heterogeneous. And then homogeneous is also a mixture of different things, but you can't see the different parts. So if you had a glass of water and you mixed in some sugar or salt and you stirred it in and that dissolved and you can't see the sugar or salt anymore, then that is a homogeneous solution. You can see that throughout. Another name for a homogeneous mixture is just a solution. You might hear that a lot in chemistry terms. But again, the atom structure of this, you have two or more different types of atoms or elements that are, or compounds that are mixed together, but they're not stuck together with chemical bonds. So the example was a salad, or for a suspension, which we're not really going to talk too much about, we have a snow globe. So like those pieces of snow would be suspended within the snow globe. You can see them. Colloid's kind of like a suspension. There's pieces of white chunkies at the molecular level, and milk. Kind of looks like a solution. It looks the same throughout, but it's really not quite homogeneous. But then like a glass of hot tea, there's no ice in it or anything. It's just tea. Kool-Aid works the same way. It's a homogeneous mixture or solution. This chart will come handy to you. I would copy it down somewhere if you take notes. But it's you start out with a piece of matter, and you have to ask yourself certain questions to figure out what it is. So, is that matter able to be separated by physical means? Can you take out the different pieces without undergoing a chemical reaction? If the answer is no, then it has to be a pure substance. And remember, our pure substances are either elements or compounds. So can you undergo a chemical reaction and decompose those molecules, that piece of matter? If the answer is no, then it's just an element. You can't decompose an element because it's all one type of element. But if the answer is yes, then you can break the elements apart within a compound. So that would make it a compound. And then if you want to go to the mixtures, if you can physically separate it, then the mixtures, you have to ask yourself, does it look the same throughout? Or can you see the different pieces? If it looks the same, then it's a homogeneous mixture. If you can see the different pieces, then it's heterogeneous. That is all for the notes today. Make sure that you answer all of the questions on a piece of paper and turn it in tomorrow.